My name is Anna, and together with the rest of the Xomnians, I'm very happy to welcome you here tonight. First, before we start, I would like to share a few words about Xomnia. Xomnia is a data and artificial intelligence consulting company, and we have mostly technical roles here, such as data engineer, machine learning engineer, data scientist, analytics translators. And we are with around 80 people. We were founded in 2013, so we are almost celebrating our 10-year anniversary. The topic of tonight is, of course, machine learning engineering. And as a machine learning engineer at Xomnia, you would often implement machine learning solutions at clients or help building a data platform. We do this for a wide range of clients in retail, but also in other sectors such as energy. And we are always looking for new colleagues. So if you are interested, you can contact us via this mail or always talk to someone that, like Daniela or other Xomnians that are present here tonight. There are some spots still open at the front. Also, near the entrance, the presentation is streamed. So if it gets very hot in here, you can always flee to the front to watch it there. And that's it. I would like to give the floor to the first speaker, Simon Stiebellehner. Please give him a warm welcome, and I hope you enjoy the presentation.
Perfect. Thank you very much for the warm welcome. Just let me know, by the way, if I run around too much and I move too far away from the microphone. That typically happens, but just give me a shout and I'll try to move back closer to it again. Well, first of all, thanks a lot for having this evening together with us in this talk. The first talk from, TMNL is going to be around scaling the fight against money laundering with machine learning operations. So MLOps at TMNL in a nutshell. But before we dive right into the reason why you guys are here, which is probably machine learning operations or data science, I think there is one topic that is a lot more important than that we should at least spend 5 minutes on talking about. And that is money laundering. Who of you kind of knows what money laundering is? Maybe raise your hand briefly. Okay, I would say that's around 50%. It's a good portion. Well, money laundering is, here we have it, yes, money laundering is essentially hiding where your money comes from. Concealing the origin of money, if I'm going to put it in nice terms. But why would you actually want to do that? I mean, if you ask me, Simon, where do you have your money from? Well, I'm going to tell you, well, I work at TMNL. They pay me a salary, and that's where I got my money from. What reasons are there why you would not want to say where you got your money from? Oh, thank you. There it happened, I knew it. Any ideas? Why would you want to launder money, actually? Taxes, I heard.
Illicit activities.
Malicious activities? Illicit activities. Oh, that's very correct. Absolutely. So typically, you do not want to say where your money comes from if you have earned it through some illegal activity. And that can be drug trafficking, human trafficking, terrorism, whatever. Yeah. Well, and why would you not want to do that? Imagine you pulled off a drug deal, a major, well, not a major, let's say a minor drug deal, and you got this suitcase of cash. Yeah? You got this suitcase of cash, let's say €1 million. And you really want to buy a Lamborghini with it, because this is your life dream, right? You want this yellow Lamborghini in front of your flat here in Amsterdam. Well, so you're gonna give that a try. You're gonna take that suitcase of money and go to some drug dealers. Sorry, to some car dealers, almost. and well, you want to buy that Lamborghini. You will find that it's actually super hard to buy a Lamborghini with a suitcase of cash. Yeah, nobody actually wants that. Because your money seems to be a bit smelly. Yeah? It is a bit fishy. And also, they're not really allowed to give you a Lamborghini for a suitcase of cash. Yeah, that's a bit illegal as well. So obviously, you're going to be a bit, damn, so how am I going to get my Lamborghini? So you do some Googling, and you read that term that says, oh, money laundering. You do some research on Wikipedia or whatever, and you find, yes, this is actually what you need to do to buy that Lamborghini. So that's what you do. you try to launder that suitcase of cash, your money. And you're typically doing that by placing it somehow in a financial system and then funneling it through that system. You funnel it through that system so that in the end, it seems as if you got that money from a legal source. It seems quite fine. And then congratulations, you have succeeded. You can now buy your Lamborghini, finally. Your money is now clean. It looks legal. It's probably on your bank account. You can now buy your Lamborghini. Well, when we think about money laundering, when people hear it on the news, when they hear it on the radio, often money laundering seems like a bit of a white-collar crime. It doesn't seem that bad, right? It's someone has money and launders it, and then there is money again. So what is well, it doesn't seem that bad. However, it turns out that money laundering is actually very, very bad. It's a massive issue. Why is that the case? Well, first of all, it's a massive issue because simply it's massive. Size-wise, it's incredibly big. Just in Netherlands, an estimated 16 billion euros are laundered every year. And that number has been growing year over year over year. So it's actually a really big issue, especially in the Netherlands. Another thing, and that is what many people do not realize, is that if money laundering would not be possible, this would actually have a significant impact on organized crime. How come? Imagine again, you have your suitcase of cash. You pulled off the drug deal, there is €1 million in there, and you want to buy your Lamborghini. This is why you pulled off that deal in the first place, right? You want to buy something from your money. Now imagine you lived in a world where money laundering was not possible. You have your suitcase of cash, but it's literally worth nothing for the simple reason that money is only worth as much as other people want to trade goods for that money with you. If you cannot trade goods because it's dirty money, well, then this is actually not really worth anything. And of course, you're going to ask yourself, well, why did I commit that crime in the first place? I cannot do anything with this pile of cash now. So this really shows that if we got in control of money laundering, we basically take the oil out of the engine of organized crime. And this is really why we exist. This is why TMNL, Transaction Monitoring Netherlands, has been founded. We are here to take the fight against money laundering at an unprecedented level, internationally even. It's actually the first time in the world initiative where banks get together, create a company, which is TMNL, and put pseudonymized transaction data of businesses together into that company with the purpose of doing anti-money laundering just the way it has never been done before. Well, you might now think, wait a minute, but all of these banks, they do anti-money laundering. And that is absolutely correct. All of these banks do anti-money laundering, and they have thousands of employees doing that, and they have highly sophisticated systems doing that, expensive systems doing that. So why would you need TMNL? How far are we different, actually, what we do? There is one key difference, and this is when you are an individual bank, what you see is what your customers do. So what goes into your accounts and what goes out of your accounts. So this means your view is actually fairly limited. Any money laundering network that spans multiple banks, multiple countries even, is kind of out of your sight. You're not going to be able to realize it, even if you have thousands of people, even if you have highly complex and sophisticated systems. And this is really where TMNL comes in. We have a significantly broader view, since for us it's nowadays at least 5 banks which allow us to have a fairly good view of business transactions going through the Netherlands. So we can even detect more complex patterns of money laundering that individual banks can't do. Well, and at TMNL, we do 2 things. For doing anti-money laundering, obviously, we build models. We build rule-based models, graph-based models, machine learning models, and my colleague Maryam in the second talk is going to talk a lot more about that modeling part. But, well, if one of your core business activities is building models, you also better be doing that very effectively and efficiently and also securely. And this is really why we are also building a modeling platform to support basically our core business process, building models. And well, my name is Stiebellehner, and I'm the, where do we have it? Yes, lead MLOps engineer, and this is also why I'm super interested in exactly that modeling platform that we have been building. And in the next, I think we have like 25 minutes left. We're going to take you from first looking at TMNL from a bird's view, so a high-level view. How and what relationship are we with these banks? Then we're going to fairly quickly step into TMNL and look a bit at, okay, how do we approach model development at scale? Yeah, what tech stack do we use? How have we been building our platform? What is our thinking about building that platform? And finally, and that's also going to be the bigger chunk, we're going to take even one more step into the model development side, and we're going to be looking at machine learning operations specifically. How do we think about streamlining our processes around model development, deployment, serving, and operations? And what role does our MLOps platform play in that? And also, we're going to be talking a bit about the golden path, how we put it from model initiation, essentially, all the way to production. But first, we need to take a step out of that rabbit hole again and talk a bit more at the bird's eye level about TMNL. So I mentioned it before, TMNL, we are a joint venture from these 5 banks. Most likely your bank accounts are also with these 5 banks. Again, no worries, we only have transaction data from businesses. And that's also pseudonymized, and that's also what we get from these banks. So we basically get massive batches of transaction data in a pseudonymized way from these banks. TMNL then does something, right? It's this magic hat here. We do what we do here exactly. We're going to be talking about in the next 2 sections for a long time. We do something. We produce something. That something is called alerts. We call it alerts. It's essentially signals that indicate that potentially something unusual with respect to money laundering is going on, for some transactions. We funnel that back to the banks, and the banks then look at that, they review that in their context, and give us feedback. So as you can see, we are in a circular relationship here. We get massive batches of pseudonymized transaction data of businesses. We run them through the magic hat. We run them through massive data processing and modeling pipelines, essentially. We provide back alerts, signals, and we get feedback on these alerts, which then allows us to improve our models, to improve our processes. But what is inside this magic hat? What do we actually do? And for that, well, let's take a step into that magic hat. And I can promise you one thing, there is no white rabbit in it, but it's actually tons of AWS when you look in there. So TMNL is cloud native AWS. So even if you don't recognize all these icons here, no worries. What you should remember is, yes, it's AWS. Another very important icon here is at the very center where it says model development. You're going to see SageMaker. Most of our MLOps and modeling platform is built around SageMaker. So basically, when you develop models at TMNL, you're going to be touching SageMaker a lot as well. Another important point at the very top. I mentioned it before, and you can imagine it. We are sitting on really, really large data sets. It's tons of transactions. So you're also going to find Spark pretty much everywhere. In our data pipelines, in our model pipelines, Spark is pretty much everywhere. Also Python, pretty much 95% of the company runs on Python, I would say. Top right, small logo. Probably you haven't noticed it. Also very important. If it's not Python, for everything that's infrastructure, it's Terraformed in our case. Well, but that's a nice slide, of course. We see a lot of icons, fancy icons. Okay, AWS, Cloud Native, SageMaker, fancy stuff, probably. But of course, how do we put that to work? So far, it's only icons listed, and not even listed, just thrown onto a slide. So we need to look at that a bit more in a context, actually. And that context should be model development for this presentation. So if you now take the perspective of a model developer, and when we talk about model developer, what we mean is data scientist or machine learning engineer, then this is the start of your day, usually, the start of a typical day. You would typically, you start a new modeling project, you would probably start somewhere here. You would have your, in that case, Amazon SageMaker Studio notebook. You would open that. You would potentially spin up your own EMR cluster, connect it to your notebook, query some data from our data lakehouse, and then you would start exploring. And you do that exploration in what we call, well, an exploration environment that provides you regulated interactive access to data and you can do your stuff, whether that's on small data in with plain Python, or whether that's on a cluster, actually your private cluster here. At some point, hopefully, your exploration phase also comes a bit more towards the end, and you actually want to start build out your model. And in that case, that's part of what we call the golden path. In that case, you will slowly start translating what you have done in your exploration part piece by piece into pipelines. And in our case, that's SageMaker pipelines. If you're not familiar with SageMaker pipelines, I think no worries there. It's nothing but a workflow orchestrator. So imagine it like Airflow, just really made for SageMaker and really made for machine learning. So it's by far not as general purpose as other workflow orchestrators. Well, you might wonder, why? Why SageMaker pipeline? Why doesn't the model developer, I don't know, just throw everything into a container and use ECS, or why does the person not use Airflow? And I think this is an important part to understand how we've been thinking about developing this modeling platform. We believe that if you want to achieve a high degree of automation throughout your process, you need to have certain contracts and certain standardization along this process. And one very important point in this process, one very important contract, is the fact that the only thing that you can deploy is actually a SageMaker pipeline. Yeah? As long as there is one function with a specific name in your repository that returns a SageMaker pipeline, our centrally managed CI/CD pipelines will find that. They will take that pipeline, do a couple of checks on it, and deploy it to higher environments. To execution in our case. Execution is fairly different to exploration conceptually. It's no interactive access. Everything goes via managed compliant CI/CD pipelines. It is completely locked off, essentially. Absolutely no manual changes possible. But this is also at the very right then, after going through tons of checks, this is where the actual output can actually be produced and consumed by downstream applications again. This is kind of the scope of a model developer, where you spend your daily work in. Exploration, execution, that's what you develop, at least from a technical perspective. Of course, there is a lot more to being a model developer at TMNL, right? You also need to build up business understanding, converse with your stakeholders, and. But from a technical perspective, this is typically where you spend your daily life. And exactly this also defines the scope of what it should say here, MLOps platform, actually slightly cut off. This is also the path, the width, the breadth for which we've built our MLOps platform. The MLOps platform really is there to make model development, deployment, serving, operations as effective and efficient as possible. But what is MLOps actually? I do assume that quite some of you kind of know what MLOps is about, but I'm still going to spend 3 slides on making sure that we're all on the same page. Well, MLOps has become quite the hype term in the last 2 years, roughly. Nowadays, you can read a lot about it. You know, new roles have emerged called MLOps engineer and all that stuff. What it is, well, my definition, at least, you can find here. I consider machine learning operations as a set of principles and activities that you do to essentially make data science efforts, modeling efforts more effective and more efficient. This is what MLOps is, at least if you ask me. But why has this been such a hype in the last 2 years? And why is it probably still going to be a hype in the next 3 years? There is a very good reason for that, actually. You can relate to this very well. In many organizations, when you actually want to take a model from initial development, from exploration, all the way to serving it, monitoring it, and iterating on that process, you might sometimes feel as if you were in a 1900 factory here. Yeah? So it feels painful. It feels there are no processes how to do this. It can feel like it's tons of inefficient manual work because every team does it individually, slightly different. There is not the scale potentially to automate it. There might be lots of handovers, especially if you work in a large organization where you might have a data science team that works on notebooks, then throws over the notebook to a machine learning engineering team that catches the notebook, butchers it on the way potentially, puts it into something that's deployable, and throws it over to a DevOps team again to deploy it. That, of course, together with a lot of manual work, will make this process super error-prone, and in the end, you're going to end up with an incredibly slow iteration speed. And slow iterations really is what kill the value of machine learning systems, because if you cannot iterate close to your user fast, you're not going to be able to improve your model where it matters, and that is close to production, close to your user. And this is reality in many organizations. This has gotten a lot better already, I think, in the last few years, but in many organizations, this is reality. And this is also exactly where machine learning operations comes in. In MLOps, we try to turn this 1900th century factory into a 21st century factory. That means streamlined processes, a high degree of automation, resulting to fast iteration cycles, resulting in little deviation in quality. Right? All these things you're used to from a modern factory. When you Google machine learning operations, or when you follow some people on Twitter or LinkedIn or whatever that talk about machine learning operations, it will sometimes feel as if MLOps really is all about tooling. Well, I believe MLOps is really not that much about tooling, actually. I think if you want to build a successful MLOps domain in your organization, you should not be tooling focused, but you should really be thinking more about how are modern factories actually built. Yeah? How do you build a model factory, a modern model factory? And you will quickly realize that also, even in physical factories, people do not start with choosing machines first. They first start with understanding the processes. They need to understand, and that's pretty much the same when you build an MLOps system, or an MLOps platform, you need to first understand how do teams in my organization actually develop models? How do they do that? What works, what doesn't? Where are the inefficiencies? Where are the pain points? Yeah. Then what does my target process actually look like? My golden path, so to say. This process that I can streamline, that works for at least the very majority for the teams, that we can streamline, that we can automate, that we can continuously measure and improve. Yeah. So it's really, actually, especially in the beginning, a lot more talking to people, drawing process diagrams, and evaluating processes, and trying to find a common denominator, which then is the golden path, and then building towards it. And then only when it comes to actually automating that process, this is actually where then tooling starts to matter. But really, the more important work typically happens before choosing a specific tool. It's all about understanding your process and your users. Well, that's been a lot of theory now around MLOps. So let's now look into how we've done stuff practically at TMNL. You already know this diagram. This is kind of what I said before. This is like the daily life of a model developer, at least from a technical perspective. And in the next few slides, you're going to see some patches popping up. Patches like on the very top right. The light blue patches or light gray patches, they are features, things, infrastructure, tooling that is spun up for your specific model project when you create a new model project. Right? So this is really model-specific infrastructure and tooling created just for you when you initiate a new model project. Whereas the dark blue, dark grayish patch, that's shared tooling and infrastructure that is shared across teams, for example. So typically the process when a team says, okay, I want to start a new modeling project, right? A new project was confirmed that we want to start this. They will create a pull request specifying, in a nutshell, the name of their model. A bit of more Terraform code, but that is essentially copy-paste for now. What you really need to specify is the name of the model, as well as which type of model are they building. Are they building a rule-based model, a graph-based model? Are they building a machine learning model, a supervised model, for example? Depending on what they specify, we spin up different infrastructure and tooling for them. One thing that they always get, obviously, is a remote repository with approval rules that guarantee that anything that goes towards execution has seen 4 eyes. So that enforce 4-eye principles. Also, depending on which model type you're going to build, you will populate your repository with a template. Yeah? That is, depending on which model type, the template looks slightly different. And that template does 2 things, 2 very important things. On the one hand, it's the source of example usage of the platform. So it always contains the most cutting-edge features that were developed by the platform. So it's kind of a real big example usage of how to use it. But on the other hand, it also contains a minimum viable model. It contains a fully functioning model kind of a fully functioning skeleton. And that means as soon as you populate your repository with this template, the first CI/CD pipelines will kick off and also deploy that skeleton successfully to execution. That means from the first minute, you actually have an end-to-end working build and deployment process, and you do not need to build a model from scratch, but you start iterating on a skeleton instead of always building from zero. Also, you get your own scalable self-service notebook environment. You can spin up your own EMR clusters via graphical user interfaces, connect with your notebook to it to do data exploration really on large-scale data as well, next to the classic notebooks. You have a selection of base Docker images for your jobs and notebook kernels that kind of cover 90–95% of your default use case. If you need to branch out, there is a self-service ability where you can basically customize your own images based upon the base images. There is a feature library incubated by model development teams where the MLOps platform essentially maintains the framework behind it, and also there are the build and deployment pipelines, but contributors are the data scientists and machine learning engineers building models, so we can limit the duplication of building the same features over and over and over. Then obviously experiment tracking, model registries. These are actually things where I think platforms as SageMaker come in very handy, because usually they give you at least okay tooling for exactly these things, and only if you run into issues there, you need to think about doing some custom stuff. Then you get automated integration tests on high environments to make sure that your stuff actually also works after deploying. We also provide data distribution, data profilers, and distribution checkers, which are in our case based on YLogs, quite a popular open source library for data profiling and checking. What we have built on top and customized there is really tailoring it to our infrastructure, meaning taking care of storing the profiles where we need to store them, versioning them in the way that we need to version them, making them retrievable from different environments, and all that stuff to really tailor it to just what we need. Model development teams get quite some operational monitoring out of the box around pipeline runtimes, pipeline failures, how often was it executed, and all that stuff. For everything that goes beyond, we provide templates that can be easily adapted to monitoring whatever your data profilers say, for example, and same for alerting. We also provide output validation. These are essentially Python packages that check whether your model outputs adhere to the data contract agreed with downstream applications that consume model output. And we are also automatically cataloging and versioning model output. So as soon as a model runs, outputs alerts, for example, these alerts will be cataloged and will be retrievable as if you were, in a classic database, although we're operating on a data lakehouse architecture. Yeah, there is full lineage and execution. So everything you do here is stored, is versioned, is safe. You always know exactly what piece of code ran, what model was used, and all that fancy stuff. We need that, right? You also don't need to worry about mechanisms, how to parameterize or trigger your pipelines. All that is also taken care of for you. So what you can see here, all these are essentially features that together create this product, this platform, this MLOps platform that really allows us to have a very clear path to production and a highly automated one. Yeah. I mentioned before, we have what we call the golden path. It's highly streamlined. There is one way how to develop, deploy, and operate models. And this really allows us to have a 21st century factory, a high degree of automation, one way how to do things, being confident about how things are done, being confident about the security and the quality of things. Also, it allows us to have no handovers in teams. So we have teams are end-to-end responsible. And that is really allowed by the fact that a lot of the cognitive overhead that you would encounter in such an end-to-end process is abstracted away from the platform. And yeah, this is essentially how TMNL has turned into a 21st century model factory. And that's really what helps us catching criminals at scale in the end. I hope you've enjoyed the talk. If you have any questions, please just either ask now, or I'm also going to be here later, so feel free to grab a drink with me and we're going to chat a bit about it. Also, we are hiring. Please do check out TMNL.nl, right? Data engineers, data scientists, machine learning engineers, MLOps engineers. You find a lot of vacancies there currently. Please do reach out. We're based nowadays in Amsterdam, actually. Yes. Yeah, questions?
Yeah, thanks a lot. Yeah. Good evening. I'm Maryam Miradi, talking exactly about the same part, but using the very beautiful foundation that Simon already explained to you to talk about the data science part of our TMNL. Fighting money laundering explained actually very well with Simon. I'm not going to repeat that one, but I'm going to talk also a little bit about how we need actually to understand criminals before we could make models for them. So what we say at TMNL that we are actually in the business of catching criminals. That's why we need to understand that how criminals actually behave.
Just one moment, please, because they're mixing up a little bit the sound there.
Okay.
Sorry about that.
Let me get back. It goes like on the wrong direction. Fritz, can you help me? Just give me 1 second. Ja? No problem. Als ik deze doe, dan gaat hij toch naar de goede kant op. Hij gaat een beetje snel.
Of misschien naar voren.
Deze.
Ja, even.
Ja, sure. Ja, die toch?
Ja, maar ja.
Ja. Dat gaat.
Ja. Geduld.
Geduld.
Ja, hij doet heel even.
Ja, sorry. Thanks a lot. So basically what we are saying, can I start? Thanks a lot. A criminal never acts once, and also they adopt their tactics. So they don't actually stay in the same type of, how do you call it, behavior. They never act alone. That's actually one of the things that's important. They form a network, and that network also continuously changing. That's actually the base of whatever kind of modeling that we need. There are two things. It's unknown behavior, but also there is a network. So for the data scientists among us, that you immediately know what kind of actually methods we should go after. So that's the reason that we are going for machine learning, and especially unsupervised machine learning. And of course, graph analytics, which is in combination of machine learning, it makes us really strong to actually build our models. This is the part that Simon also explained. So we can build our models, and we know that we start in a notebook and just build the models. But one of the things that we needed is that the word no handover that we just built, just kind of was in the presentation of Simon, is that you need actually a very good setup of data scientists together with other expertise. So we have these multidisciplinary teams, which is we are thanks to our CTO. So you have actually all of the expertise in one team, and that makes it that you just don't start with your usual actually data science stuff and then hand it over to a group which will rebuild it and rewrite it again. But in the same group, we will have the engineers, the machine learning engineers from the team of Simon to help us actually to make our pipelines actually better, to just actually make it the same, that later on there wouldn't be a production time, but it would be immediately actually there. What kind of models do we build? Of course, as I said, graph network types of models. we build unsupervised models. And we have another category, which are where kind of ad hoc deep dives models, which we, if DMB necessarily needs actually a data or a model, we will actually do that kind of modeling. Instead of actually diving into all of the models that we have, we built in 2022 15 of them. We just narrowed down to 2 examples, which hopefully give you guys a bit of impression of what we are building. The first one is our anomaly detection model, which you could actually see as our transaction monitoring. And we have done that with isolation forest. And isolation forest is basically from a money laundering perspective is when we isolate the entities which has a odd profile. That's actually the whole point where we use isolation forest. For people who already have used anomaly detection with isolation forest, they know that it's basically a model and a kind of a tree model where you do the splitting. Looking at this, you can imagine that there are a lot of features, but let's say there are 2 of them. If you have feature 1 and feature 2, you start to split actually your tree, your isolation forest, which is same as a random forest, is a combination of a lot of trees. When the split goes very fast to a node, that node is actually an anomaly, and then we isolate our anomalies, and that becomes actually our alerts, the same as Simon explained. What kind of input we use? I would be very happy to just list all of our features, but for privacy and security reasons, I just kind of have to stay on the high level. So sorry about that. But we have business clients, so we need actually anything about the business client. Okay, when did your company founded? Those kind of stuff is actually where we look at it. So a company, then products. We are in the banking, so meaning that the products are accounts, and if you have you're a normal person, as Simon says, if you're a normal person, you have salary most of the time, you have just an account and you have a saving account. You're a company, it could be a number of them, it could be a number of them also in many banks, and that's where the whole multi-bank actually comes to play, because if you have just at ABN 1 account, you wouldn't, that's actually for ABN visible, but imagine you're a company and you have accounts through all of the 5 banks, 5 big banks, then it would be completely a blind spot for one bank to see the transaction between them. And that's where we could actually see all of those in the transaction behavior. And the transaction behavior, what we care about is specific behaviors where, as you can imagine, the connections with international, that you don't use too much of cash, those kind of stuff is where we are very interested in. One business will actually do transactions with another one. And that's where you have your counterparties, because if you're a good business, you work with other businesses, and that's where you also need features from what's happening, which comes again from your transactions. So why IF? Why unsupervised? As I mentioned just before, we are dealing with the unknown behavior as something which is like moving the whole time. So if you use supervised, which is again legitimate in many situations, this as well, in this business as well, but still you are talking about something which moves a lot. That's actually where we need the whole unknowns, and that's where we use the unsupervised to capture that actually unknown. And TMNL is founded by the banks. So what we use should have this familiarity at the banks as well. If you start something new, especially at the first rounds, or that's most of the time gives a lot of extra explainability. I will come to AI explainability later, but you need to start with things that are kind of established, but also kind of a state of art of the best, and that's the isolation for us. What we notice is that makes it very easy to explain to them. We can also combine the technology with other things. I will later on talk about network embedding, and that's could combine also we can use actually the columns. This is the part that Simon and guys has done a lot, is that we are a new company. So when we were building our models, the foundation was still building and it was moving. So it wasn't like starting having everything exactly as you would have in a company, which has a lot of advantages, but still we needed to just kind of move on and Simon is now nodding, is that how it is not always an easy task for a data scientist to just write things and know that the next day it will be a bit different and you have to change it. So it has been a part of the whole journey. So normally you could experiment much more in that sense, so just put like 10 different models, but this is like, how can you build one solid model which works for the business actually, and start from there. That's actually has been our purpose. Let's take a look at the second one, which is the community detection. Our algorithm where we basically detect groups of tightly connected nodes in one network. And because like if you just haven't ever worked with graph analytics, like finding the cool kids in the school, which has a lot of connection. Visually, huge network. You can imagine, just even look at your own normal life, how much of transaction you have. So imagine that you are a company and you are also a criminal company, so you will have a lot of transaction. That's actually where we want to have all of the huge transaction and change them to the tightly connected networks or actually set of nodes, which is loosely connected to the other one. Visually looks very easy, but when you want to do it, the first challenge that you have is how would you make that much of data to one thing which is like working and is fast enough. So scalability, as you can imagine, that has been like not an easy one. This is like a solid solution where we build full networks. We use graph frameworks. Do you remember Spark from what Simon was saying? That's actually everybody's kind of savior in the sense of it's really good for heavy lifting. So this is the part where we are doing heavy lifting. We just make the first piece of just bringing all of the connectivity to data. Then we start filtering. And filtering network, it has different things. It could be node, it could be edges. On the edge, we have, of course, the amount of transaction. And then we have, readable here? No, yeah, oh, sure, that is readable there. And then we have also the community size. Okay, I mean, what's a good community size? You can imagine that's not very easy to say. It's just like, it could be a community size of, I don't know, 20 people, or companies, it could be 200. So that's one of the things that we needed actually to play around. Then we break down the communities. Again, if you're interested in the libraries, graph frames, then iGraph, and the people who have worked with networks, they know that Network X, one of the things that you can work with it. But Network X, on that level, is not very, you would say, fast in that sense. But it has the communities, which all of the algorithms where you can work with. And that's where you, for example, do all of your network features. What's actually your density? What is the clustering density? And those kind of stuff is where at step 4 we can do. Then we rank the communities. There are a lot of them. Which one is good? Which is actually the most criminal one? And that's where we use our AML knowledge, so our experts, the AML experts who will help us to detect the communities and rank them in a good way. And then finally, we visualize them. But I just actually explained this is the way you could visualize it. You see the whole network, and you will remove the things that are. Just imagine that our data is also pseudonymized. So, for example, we don't know who is blocking this, and you can imagine everybody is like paying to blocking this. So that's actually where we have to figure out first those kind of nodes, because they are not criminals, but there are nodes that are densely, and we have to remove that, but without knowing actually how's the data. So it's pretty, like it makes it adds another layer of complexity because of the pseudonymized data. And then the next step, you basically just going, we see the last filtering, and then you see actually the communities detected at. And the last step is where I show that in a kind of loop we are doing that. This is maybe recognizable for you guys. This is where you see a triangle or a quad or a density. Why is it important? For example, in a triangle, if we will have tax criminality, somebody will send it to a next company, and then the next company will send it to another one when people don't want to pay VAT carousel, to pay their VAT, and then they get back to themselves. And some of these people will not pay VAT. And that's actually, the patterns are very important. Most of the people will send money from Netherlands to Hungary, to Italy, then to Hungary, then somewhere in Middle East, and then maybe in Africa, and then comes back to Netherlands. And that's where we want to actually know the loops. I will explain how we visualize also very professionally later, but in the first step, we have just the way every data scientist visualize it. We will use Network X and inside our notebooks. And we try to make it also a bit interactive to make it nice. So I talked about community detection, but that's one of the things that you can do with the network. So I'm just telling a little bit also what we are currently doing, because community detection is one of the ones that we have already spoken. I will get back to that karate club in a second. But that first one is the EgoNet. EgoNet is another types of groups of networks, which are same as communities, also like a group of nodes connected to each other. But the difference with EgoNet is, for each node, every person has an ego net or subgraph, which is because you guys always have a friend. It's exactly the same concept when you say, give me your friends and I know who you are. That's actually EgoNet. So every person has like a network. That network could be big or small. And that's where you bottom up, instead of breaking actually the whole network, but you build up from bottom to top. And that's actually what we are experimenting right now. Very important one is the graph edge or node embedding. These informations, when you have it isolated, is nice. Then you give it to alert reviewer and they received it, and it's very good. But you want all of those knowledge actually inside the model as well. So it adds value. So you have your normal features, but also basically how is network working without all of the decision that you have to make, which I showed you at community detection. You have to make a lot of decisions to show actually what are the communities. So if you could just capture those intelligence inside actually the features, which is like any kind of embedding. It's the same as word embedding. If you have a document, you have words. For the people who have worked a little bit with text analytics and NLP, it's very, very similar with that. And right now we are working with the library Karate Club, which is on top of Network X. It has a lot of different embedding. So this is the AI explainability that Simon just promised. Not all of these things that we are doing, we are taking care of, but also we think about AI explainability and fairness as well. With explainability, we use just sharp values. We use the global explanation to say, hey, our model generally thinks these are the most important things, but for each alert that we generate, so the local explainability, we also say, okay, this alert is generated, and the most important feature was this, and the contribution to that is about 50%. And also, as you guys know, sharp values use the game theory, and then they create actually that. Another thing that AI fairness we are working with or playing around, and we had some sessions as well, is the multi-party computation about fairness, because then you can do fairness, because a lot of time data scientists are not allowed to use gender or race or those kind of stuff, because it's just very too sensitive for fairness. But when you do it completely anonymous and use actually multi-party computation, you basically can go and do that. And almost the last piece, which brings everything together, is that our models create alerts of suspicious criminals, but you still need to make it understandable to give it actually to people. What do we do for that? Most of the people know we create an app, we create a software which brings it together. Ours is TMNL Investigator, which is redesigned and re-engineered by our Department of Digital Channels, which brings all of this in a visual way. So the alert investigator will see actually how the network works, and then the first one is like, you can see the whole network, and if they click on it, they will see the one at the right side, which is like expandable, and they will see that part of the how is actually part of other things. And with this, thank you guys for listening.